In this part of the course, we'll learn how to use analytical tools like the tornado diagram and the sensitivity map, which help us visualize the relationship between input variables, such as risks and task costs, and the output variables of the model, like the project's total cost. This visualization allows the project manager to establish the priority or hierarchy of risks and tasks, enabling a better allocation of resources to the most critical elements for the project's success. So input and output variables. We already have the output variables defined, located in the model's outputs sheet, specifically in cells B2 to B8. These represent the key results we will evaluate. However, we haven't yet defined our input variables, those that directly influence the model's results. To do this, we remove any previous configuration using the Input Data button under the Remove Input tab, leaving the selection blank. By doing so, the EasyRisk Quantum software will delete all previously defined input variables. We can confirm this step by clicking the Show Inputs and Outputs button, which should now display an empty space. Now we proceed to define new input variables. From the Map tab, we begin setting up the input variables. The first 10 rows correspond to the project's 10 main risks. In cell C3, we reference the stochastic behavior of a specific risk located in the risks sheet column T. This formula is then copied down to row 12 to cover all 10 risks. It's important to note that these cells will change value every time you recalculate the simulation, as they are stochastic in nature. Now we incorporate task costs. We now turn to the costs associated with tasks. In the cost sheet, you'll find the fixed and variable costs of the project's 28 tasks. This variability includes uncertainty in both costs and task durations. In column O, starting at cell O3, we find the total cost per task, which includes both fixed and variable components. This is copied down for 27 rows covering all 28 tasks. So we now have 10 risk-related variables and 28 task-related variables, all ready for simulation. Now we calculate total costs and means. In cell C2, we sum the values to obtain the total project cost per iteration. This value will change every time a new simulation is run. Next, in column D, we use the function EasyMean, making a reference to C2 to calculate the mean, that is the expected value of each variable. This is copied down for all rows of risks and tasks. It is normal for these cells to initially return errors if no simulation has been run yet, or if the cells haven't been formally declared as input or output variables. Now we calculate the relative contribution. In cell E3, we define each variable's percentage contribution by dividing its mean value by the total project cost, making the total project cost as a fixed reference. This formula is copied down, resulting in a relative impact measure for each variable. We now apply the function equals rank, open parenthesis, D3, comma, and then the range D3 to D40, close parenthesis, which is, by the way, a fixed reference, to generate a numerical ranking from 1 to 38, sorting all variables by their contribution to the total cost. This tells us which risks and tasks have the greatest influence on the project results. Finally, we declare the input variables. We select the range of cells from D3 to D40, which contain all relevant variables. Then we go to the Input Data button and confirm the selection. Thanks to the labels in the adjacent column, EasyRisk Quantum will automatically assign the correct names to each variable. At this point, the model is fully ready to run a simulation. So we run the simulation and analyze. We run a simulation of 1,000 iterations using the Parameters button or directly through Simulate. This will generate and store the results for all declared input variables. In this case, we're working with mean values, as summing percentiles is not mathematically correct. Once the simulation is complete, we'll have in column D the mean values of costs. In column E, the relative contributions. This information is now ready to be visualized graphically. So, visualizing the results. This information is displayed in a map style chart where we use conditional formatting to highlight the most relevant elements. For example, we see that tasks 23, 24, and 25 together account for 54% roughly of the total project cost. Other highly impactful elements include technical and integration issues as a risk, number 4, and database design as a task, number 5. This chart gives us a visual and quantitative view of the most significant risks and tasks in terms of their economic impact.